This is 2007 AP Physics B question FRQ, and now this subject is covered in AP Physics 2. So the questions changed a little bit since AP Physics B was split into AP Physics 1 and AP Physics 2, but the concept that you have to learn is still the same. So I'm just going to go over this question. So you see some of different types of FRQ related to geometric optics. So the student is asked to determine the index of refraction of a glass slab. She conducts several trials for measurement of angle of incidence. So theta A is angle of incidence in the air versus angle of refraction, theta G, in the glass at the surface of the slab. She records her data in the following table. The index of refraction in air is 1. So plot the data using the graph that is provided, and the coordinates of the graph are going to be sine theta A over sine theta G. So the x-axis is going to be sine theta G, and the y-axis is sine theta A. I'm going to ask you to pause the video and copy either the table or the graph, or take a picture of the screen and try to plot it yourself. And I'm going to do plotting myself as well. So look at the table. I'm going to have it on a different screen as well to do the graphing, and use this table to plot your points for theta A and sine of theta B. And I'm going to do the same. After you unpause it, we should have the graph. So here I have the points for sine G and sine A. So for point 9, I have point 14 for sine theta A. For point 26 on G, I have point 36 on A. Sine of sine theta G is 0.42 when sine theta A is 0.63. And again, the last one is 0.57 on sine G on x-axis and 0.83 on y-axis for sine A. Now I'm gonna approximate what the graph is gonna look like. And here is my graph. I'm gonna write the coordinates of the points as well. For the next question, they say to calculate the index of refraction of the glass slab from your best fit line. So from Snell's equation, we have N1, or let's call it N air, sine theta air is equal to N glass and sine theta glass. Index of refraction for the air is 1, and then I have sine theta A, and then I have index of refraction of the glass and sine theta G. So NG is equal to sine theta A over sine theta G. And if you think about this equation, y is equal to mx plus b. If your b was equal to 0, then you have the slope is equal to y over x. It's the rise over the run. So I can use the same trick to calculate my index of refraction. It's the change of sine theta A over the change of sine theta G, which gives me the slope of this graph. So NG is equal to the rise. I'm going to use the points that I have for y-axis, the final 0.83 minus initial 0.14. And then for the x-axis, I have the final 0.57 minus initial 0.09. And that gives me the slope, or the index of refraction for the glass, is equal to 1.44. for the next question, they say describe how you could use the graph to determine the critical angle for the glass-air interference. Do not use the answer in the part B for this purpose. So because from Snell's law I have N1 sine theta, let's give it again, air is equal to N glass sine theta glass. The critical angle is where the angle with the surface is equal to 90 degrees. So if this is your surface and the light is coming out of the glass into the air, so here is air, this is glass, then the incident angle is going to be theta A, that angle, but your refracted angle is 90 degrees. So for that purpose, or under these conditions, sine theta G becomes a 1. So you would have Ng times 1. So when sine theta G is 1 and A is 1, you will get sine theta A is equal to just the index of refraction, which is Ng. And then from here you can calculate the critical angle is the arc sine of the index of refraction, or the slope of your line. And that will give you theta A, which is the critical angle. And then for the last part of this problem, they say on the graph, in the one that we have in part A, sketch and label a line for a material that has higher index of refraction. So if you had a material with a higher index of refraction, then your graph would be higher slope. So the new graph could be any line that has a bigger slope or a steeper slope compared to the first one. And that was it for this question. It wasn't too long. That was AP Physics B from 2007 FRQ. And thank you for watching. I hope I see you in the next one. And if you like the videos that you're watching, go ahead and subscribe. Thank you.